Hello friends, today we are going to start with a new chapter in chemistry for standard 8th ICSE, and the name of the chapter is atomic structure. So it is based on page number 34 of Viraf Dalal textbook. So one sec. So what you are going to study now is about the atomic structure. How did the structure was formed? What is the structure inside the atom? What are the things inside the atom? And what is the story behind how the electrons, protons, and neutrons came into existence, or basically were discovered by which scientists, and what is the procedure used for discovering it? So all these things comes under the category of atomic structure. So when we talk about atomic structure, the first thing is the introduction wise, it is the word atom is a Greek word meaning indivisible. So the word atom is a Greek word and the meaning of the word is indivisible, because initially it was considered that the atom is indivisible. So atom is the smallest particle which is indivisible. That's why the name atom was given to the substance. Since it was considered an ultimate particle beyond subdivision. So it was considered that it is the ultimate particle. You cannot divide atom any further. That's the reason it was given the name atom. The concept that all matter consists of extremely small particles was put forth by Indian and Greek philosophers, and later when John Dalton developed his atomic theory. So Indian scientists, Greek scientists, they were the one who initially gave the idea that each and every particle is made up of, the smallest particle is the atom. So it was later on John Dalton, who is one of the most famous scientists for atomic structure researchers. He gave his atomic theory, and that was what changed the thought process of the people about the word atom. Various scientists including J.J. Thomson, Goldstein, Rutherford, Chadwick and Bohr further contributed to the discovery of the ultimate particle, the atom. So it was not just one person who discovered the complete atom. It was many scientists working on many years together, and then they found that what actually the atom is made up of. So that's why we can see there are various scientists like J.J. Thomson, Goldstein, Rutherford, Chadwick and Bohr. They gave it's a combined effort by all these in different years and different time period, that we are now able to say that what exactly is atom made up of. So let's now say structure of atom, ancient view of the atomic structure. So originally, when the atom was just said to be as the smallest particle, at that time what were the views of the people regarding, or the views of the scientists regarding that atom, is what we are studying now. Kannad, concept of an atom. So as we said earlier, that Indian scientists were involved in the discovery of atom. So accordingly, the Indian scientist is Maharishi Kannad. Maharishi Kannad was the person who gave us the theory of Anu and Parmanu. Okay, Anu means molecule and Parmanu means atom. So Kannad, an Indian philosopher, conceived that matter is made up of particles called Parmanu, that is atoms. He said that a binary atomic compound is formed when two atoms combine and are called is Dhyanuka, and further combination results in Trianuka. So he said that when the atoms are going to combine together, so when two atoms combine together, that is Dhyanuka. Dhyanuka means two. So two combine, two Parmanu, so Dhyanuka, so that is two particles. And if three atoms combine together, then it is called as Trianuka. So, and further combination is called as Trianuka. And then came the famous Dalton's atomic theory in the year 1803. John Dalton, 1803, theory explains successfully a number of chemical observations such as laws of chemical combination, but failed to explain the difference shown by elements towards different chemical activities. So John Dalton was at the foremost where he gave certain theories of his which gave us an idea that how the atoms are combining with each other and how the chemical reaction takes place. But somewhere he was not able to say, or he failed to explain, that how does the element is going to have different chemical activities going to take place between the element. How the different chemical activities take place between them is not able to, he was not able to explain that particular part. So first of all, let us understand that what exactly was the John Dalton's atomic theory, or the postulates of the main postulates. Postulates means main theories or main points, okay, more important points. So more postulates. The main postulates of Dalton atomic theory are: first, matter consists of small particles called atoms. So first and foremost thing is that matter, any matter is made up of small particles which are called as atoms. So atom, it is the particle, or the matter is made up of small particles called atoms. Atoms are indivisible and cannot be created or destroyed. So now the main thing is that he confirmed, or he basically gave the statement that atoms are the ultimate particle. You cannot divide them further. So it is indivisible and cannot be created, nor it could be destroyed. So atom is indivisible and indestructible. So neither you can create it nor you can destroy it, and at the same time it was indivisible. Now you will find that the modern atomic theory is slightly different from Dalton's atomic theory. So whatever differences are there, we are going to study later that what exactly is the difference between the Dalton's atomic theory and the modern atomic theory. And at that time we will just discuss that whether it is worthwhile or whether it is fruitful to say that Dalton's atomic theory is wrong. Okay, we'll just discuss that thing once I complete the postulates and their discussion or contradiction of the Dalton's atomic theory. So atoms of the same element are alike but differ from atoms of other elements. So he said that atoms of the same elements. So if I got chlorine, two chlorine atoms, they will be of the same kind. Hydrogen atoms, yeah, they will be of the same type. So he said that atoms of the same element are going to be alike but differs from atom of another element. So of course one atom of one element and another element of other element will be different by nature. Fourth point, compounds or molecules are formed when atoms combine with other atoms, okay, and in simple whole number ratios. So it says that compounds, or we can say molecules, are going to be formed when atoms are going to combine together, and this combination is in whole number ratios. That means there cannot be a combination of one oxygen atom with half a hydrogen atom. Okay, no, not possible. If it is like that, then it will be one hydrogen atom and two oxygen atoms. Okay, it will never happen that iska half, ya iska 1/3, ya iska 1/4, and you are not able to have any compound which will be formed by half or basically fractional number of atoms. So the number of atoms present in a molecule will always be in whole numbers. So molecules are going to, or the compounds are going to be formed when combination of atoms takes place in whole number ratios. And the final point is, an atom is the smallest unit of matter which takes part in a chemical reaction. So he said that atom is the smallest particle of an element which takes part in a chemical reaction. There cannot be anything else smaller than an atom which is going to take part in a chemical reaction. So we saw the 5 parts over here. So what are the different 5 things what they give you? So first of all, we say John Dalton. So John Dalton gave us the 5 postulates of the thing. First thing is that matter consists of atoms. Matter made up of atoms. So that is the first thing, that matter is made up of, all matter is made up of atoms. Secondly, it is given that atoms are indivisible and they are indestructible and cannot be created. So it cannot be created. So it cannot be created nor it can be destroyed. The third thing is that atoms of same element, we can say atoms of same element are same, different. So if they are of different elements, they will be different in nature. The fourth point is that they compounds. So compound and molecules formed by whole number ratios of atoms. Okay, and finally the fifth point is that atom is smallest unit of chemical reaction. Okay, so it is, first of all, he gave this particular 5 postulates. Now what happens is that as the science goes ahead and as there is more and more inventions and discoveries taking place, so the microscope was made and the compound microscopes were made, electron microscopes are made, and accordingly you are able to find out, or we were able to find out, the people were able to find out that atom is not the ultimate particle. It is still divisible into protons, electrons and neutrons, and hence we found that all these 5 points, okay, they are not absolutely correct. Some are correct, some are wrong. Or we can say there needs to be some kind of a modification required in the atomic theory given by John Dalton, and this modification के साथ में जो इन लोग ने atomic theory बनाया, that particular atomic theory is called as modern atomic theory. So that's nothing but modern atomic theory. So let's see what is the difference between the modern atomic theory and John Dalton's atomic theory. So Dalton's atomic theory says that atoms are indestructible. Okay, we say that the first point over here is, we say atoms are indestructible, but we know that atoms get destructed when they are what we call it as the radioactive materials. So the radioactive materials, you don't need to go into detail of that, but when we have a radioactive material, the radioactive material, it decays and it gives away alpha, beta and gamma particle radiations. So what exactly is happening is that atom is getting split into smaller particles, and that's why we say that yes, it is destructible. So yeah, the modern atomic theory says it is destructible. Dalton's atomic theory, it is indivisible in smallest particles. So we know that it is indivisible in smallest particle, but we know very well now that atom is divisible and consists of protons, electrons and neutrons. So what we say over here, it is divisible to protons, electrons and neutrons. Right? So it is, we need to modify our thought that yeah, atom is divisible because atom is made up of 3 particles, that is protons, electrons and neutrons. Protons being positively charged particles present in the nucleus, electrons being the negatively charged particles which are rolling around the nucleus, and the neutrons is inside the nucleus, which is neutral charge, means no charge. The next is, atoms of the same element are alike. We say that atoms of the same element are same, they are alike, but that is wrong because there are isotopes. So isotopes of same element are different. Now Atoms of the same element may not be alike, as we see, as is seen in the case of isotopes. Now, what are isotopes? Isotopes are basically these atomic or the atoms of the element in which the number of neutrons are different. See, number of protons and number of electrons is the same in all the isotopes. So if I take, let's take an isotope of hydrogen. So in case of a hydrogen atom, the hydrogen has got such a way that hydrogen has got three isotopes. One has got, see, it has got one proton, one electron. That is one kind of isotope. Another isotope is one proton, one electron, and one neutron. And the third one is one proton, one electron, and two neutron. So here the number of neutrons are 0, whereas here it is 1 and 1, here it is 2. So you can see that hydrogen, now we do not name this differently because the number of protons and electrons are the same, because the number of protons and electrons are the one which are going to take part in the chemical reactions. And so valency and everything is dependent on the protons and electrons. That is why the atomic name, atomic number, and hence the element remains hydrogen. But due to the difference in the number of neutrons present in the atom, the atomic mass is going to change, because atomic mass of this will be 1 because of 1 proton, of this will be 2 because 1 plus 1, and this will be 3, that is 2 plus 1. So atomic masses are going to be different, so the properties are slightly going to be different, and hence we see that hydrogen, ये तीनों के तीनों hydrogen ही है, तीनों के तीनों hydrogen है, but one is having the mass of 1 AMU, atomic mass unit, another one is having in 2 AMU, and the third one is with 3 AMU. So because of the same atomic number but different atomic mass numbers, they are called as isotopes. Okay, they are called as isotopes. What is it? Is isotopes. Okay, so due to the presence of the isotopes over here, we cannot say that this particular thing is true. So what we found was this was not true, this was not true, and this was not true. These three things out of the other ones are all correct. This is also correct, this is correct, this is correct, this is correct, and this is correct. But these three things over here were incorrect. Now I was just telling you that I would not, personally if you ask me, I would not say that John Dalton was wrong at that time. It is not that he, because many of you may be thinking, अरे वो wrong था तो हमने उसको क्यों पढ़ते हैं? Right, the point is that in 1803, when there were no electron, no microscope, and there was no great deal of technology over there, at that time, giving this kind of a postulates, which is almost correct, okay, we are not able to find out any kind of a fault in that, then we say that this thing is absolutely okay for a person doing this thing in the in an age which was 1803. Okay, so that's remarkable in fact that to give such a kind of a output at that time. See, another thing is that when I say that it is indivisible and I am getting the divisible, when it is divisible, I came to know that it is divisible because of proton, electron, neutron. Try to understand one thing, and that is proton. If I take a proton in my hand, okay, if I have a proton in my hand, can I identify that वो proton कौन से element का है? नहीं. If I have an electron in my hand, can I identify that वो कौन से element का है? No. Can a neutron tell me that अरे मैं तो hydrogen का neutron हूँ? नहीं. They are not going to be. See, protons, electrons, and neutrons are present in all the atoms, and it is the number of protons, number of electrons, and number of neutrons making it into one element. So the moment I am taking a proton, that proton has lost its identity. Okay, if I take an electron, the electron is just an electron. It could be of hydrogen also, chlorine also, or sodium also, potassium also, or uranium also. So it has not got any identity. So when I say that this proton, electron, and neutrons atom is divisible into this, at this particular point they are not having the identity, and that is why Dalton was not able to find out because they did not have their identity. So anyways, you did not worry about this thing in deep, because it is just a thought process. So it is just a basically kind of a information what I would like to share with you, that I really like the way John Dalton had given the information at that time, and that's why whatever thing what we feel he has given us wrong, or he had given us wrong, that part is actually, I would not say it as wrong. Yeah, he was partly incorrect would be the right thing to say, rather than saying that he was wrong. Okay, so the modern atomic theory correlates with Dalton's atomic theory in the fact that atoms are the smallest unit or the matter taking part in the chemical reaction. So this particular part, that the smallest unit which is taking part in a chemical reaction is an atom, that is absolutely correct, and that is the reason there is no meaning of, even if it is divisible, that it is protons, electrons, neutrons. There is no point. Atom अगर proton, electrons और neutrons में अगर divide हो भी जाता है, तो it is not going to give you any kind of identification, and that's why we see that the Dalton's atomic theory is very, very, very important. So yes, you may be having a question in the examination, write the postulates of the Dalton's atomic theory. So you need to write these 5 points. Of course, it's just a point, so you need not learn it by heart, word to word. You can write in your own words also. But yeah, there are basically 5 of them, so all 5 of them will be required to be learned. Yeah, you cannot just write any 3 or any 4 or any 5. You have to write all the 5 of them. Okay, so that was about the structure of atom in the ancient history point of view. Now we see the discoveries of the different kinds of the divisible. So we came to know that atom is divisible to protons, electrons, neutrons. So how did it happen, or what was the who discovered it and how did he discover it? So let's study about that particular part of the chapter. So we come now to the first thing, and that is the discovery of electrons. So in the discovery of electrons, we see that first of all we understand that the atom is divisible into 3 parts. So if you just see a simple diagram of an atom, it is this way, that an atom consists of a nucleus. The nucleus contains the number of protons and the number of neutrons. Like for example, if a particular kind of an atom has got 10 protons and 10 neutrons, then it will be something like this, and then there will be such kind of energy levels called as the orbits, and in that orbit there will be electrons which are revolving in it. So electrons, that is the negatively charged particles, are going to be present in this particular orbit. So accordingly you will be having the electrons like this, 1, okay, so this is where the electrons are present inside it. So we see that these are the electrons, these are the protons, these are the neutrons, and this particular part is the nucleus, and this is the orbit. Okay, the orbit in which the atomic orbit in which the electrons are revolving. So discovery of, before we start with the electrons, so electrons, before the electrons could be discovered, the reason that the electrons got discovered was the discovery of cathode rays. Now cathode means negative charge. If you take a battery, the battery के ऊपर positive और negative लिखा था, तो negative जो है उसको cathode बोलते हैं. Okay, the negative, so it is cathode. So cathode is negative charge. So the battery का जो negative part है, the flat part, not the ऊपर का tip part, the नीचे का flat part जो रहता है उसको cathode बोलते हैं. So yeah, cathode rays leading to the discovery of electrons. So scientist William Crookes in 1878 he discovered the cathode rays. So what he took was a discharge tube, and an electric charge was passed through a tube containing a gas at low pressure. Blue rays were emitted by the cathode negative plate, which were called cathode rays. Conclusion: cathode rays were thus discovered, leading to a discovery of electrons. So it was seen that if they took a tube, so they took a tube over here, and inside the tube they took 2 So electricity was made to pass through the parts over here, and this was, of course, this was connected to a battery like this. So it was connected to a battery in this particular manner, and in fact discharge tube and a vacuum is there. So it was such that it was, this part was connected to the negative terminal and this was connected to the positive terminal. They are not given a battery, they are not shown the battery over here, but they are just connected it to a discharge tube, and there was vacuum inside. This is a vacuum tube, and on connecting this thing, so they have just connected it. This was, electricity was given to it. So they are seeing blue colored rays were passing from here towards the anode. So this is called as the cathode, and this part is called as the anode. Anode are positive charge, cathode is negative charge. So they saw that there was a blue colored ray passing from the cathode towards the anode, and this particular ray was called as the cathode. So this blue rays, what you can see, are called as the cathode rays. Okay, it was the cathode rays which was discovered by William Crookes. Now let's see the discovery of electrons. Scientist J.J. Thomson in 1897. So you can see that in 1878 William Crookes discovered the cathode rays, and after almost like 9 years it was J.J. Thomson who, with the help of the cathode ray tube, discovered the presence of electrons in the atom. So J.J. Thomson in 1897 discovered the constituents of cathode rays particles that contains electrons. So he discovered, so up till now it was just discovered that the blue color ray is being formed, but what is the content of the blue color was not known. The people didn't knew that, or the scientists never were able to find out that what was the content of this particular blue colored rays. It was J.J. Thomson who discovered that the rays which were they formed were of the electrons. So electrons was given out by that particular part. And how did he find out was that in this particular tube itself, he put another, what he did was that he placed another positive charge over here and a negative charge over here. Okay, and on doing so, he found that these rays which are going straight, they just bent down. So they bent towards the positive terminal. So because they bent towards the positive terminal, it can be indicated that this particular particles were negatively charged. Okay. So J.J. Thomson studied the characteristics of constituents of cathode ray. The ray where kinetic energy have kinetic energy and can cast a shadow of an object in their path. He also saw that cathode ray were deflected by the positive charge plate. So what he could see was that, first of all, if I place anything over in between, it was casting a shadow. So it was something like light rays which is casting a shadow. Secondly, we found that if I place a positive plate over here, then the rays were getting attracted towards that particular. So these two things made him understand that the conclusion was that cathode ray consists of negatively charged particles known as electrons. So this was the thing that he gave, that the cathode rays are made up of negatively charged particles called electrons. Since all electrons are identical and atoms of all types contain the same particle electrons, so all electrons are identical. It is seen that all the electrons are identical and atoms of all the elements, they have the electrons present in them, and they all are of same type. So electrons in any particular kind of an atom, they will be of same kind. Since an atom is electrically neutral, it must contain some oppositely charged particles. Now the main thing was that they came to know that, okay, यहाँ पे कुछ तो है. They didn't knew the structure at all. This structure was not known at all. They just knew that atom is something like this. This is an atom. And now they came to know that inside this atom there is some negative charge. Because of this thing, they came to know there is some negative charge present in it. But at the same time, they also know that this overall is neutral. So that means it is neither positive nor negative. That means that if it is neither positive nor negative, and if it has negative charge in it, there has to be some number of positive charge also in it. So that is what they proved, that since atom is electrically neutral, it must contain some oppositely charged particles. This conclusion further led to the discovery of positively charged particles, protons. So this is how the electrons were discovered in the structure of atoms. We now continue with the discovery of protons in the next video.